All right, class, we're going to continue talking about solutions, and now we're doing some diagrams, some pictorial representations of solutions. So the following graphics are going to be used while we're going through these notes. The sodium ion, chloride ion, magnesium ion, sulfate ion, and glucose molecules will all be represented by a circle, but we're going to have letters in them to represent what each particle is. So let's get started. If I have a 1.0 molar sodium chloride solution represented by this drawing, and obviously it's just a exaggerated representation, molecules would be much smaller than this, and ions would be much, much smaller than this. Okay, the drawing on the left represents a 1.0 molar sodium chloride solution in a 1 liter container. The container on the right is a 2.0 liter container. Draw the particle representation of 1.0 molar sodium chloride solution, so the same concentration that's consistent with the drawing on the left. All right, so what we're getting is if this represents 1.0 molar sodium chloride in a 1 liter container, how would I represent the same concentration in a 2 liter container? Well, 2 liters is twice the volume. If I've got the same concentration, I would also have to have twice as many particles. So that's what I would draw. I would draw twice as many particles, twice as many sodium ions, and twice as many chloride ions. Over here I have 1, 2, 3, 4 sodium ions. Over here I should have 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we should have 8 chloride ions. 1, 2, 3, 4 over here. So I should have 8 on the other side. 1, 2, 3, 4, 5, 6, 7, and there's one more right here, 8. Let's do another problem. The two containers below are 1.0 liters and 2.0 liters respectively. Draw a particle representation of 0.5 molar sodium chloride solution that's consistent with the 1 molar sodium chloride solution drawn above. So going back to the example we had, in our 1 liter container, I had 4 of each type of ion for a 1 molar solution. 0.5 molar is going to be half the concentration, so we should have half as many particles in 1 liter. Half as many particles in the same size container. So 2 of each, 2 sodium ions, 2 chloride ions. Now, if I wanted to go to my 2 liter container, again, to maintain our concentration, it's the same concentration as the other beaker now. We're just going to have twice as many particles over here because it's twice the volume and we want the concentration to stay the same. All right, let's do another problem. The following graphics are going to be used. I've got magnesium chloride. Now you notice I've got 2 magnesium ions and I've got 4 chloride ions. I've got twice as many chloride ions as magnesium ions in this drawing. It's because of our formula. There are 2 chloride ions for every 1 magnesium ion. Keep that in mind. Okay, the drawing on the left represents a 1.0 molar magnesium chloride solution in a 1.0 liter container. In the other 2 beaker diagrams, draw the particle representation of 1.0 molar NaCl and 1.0 molar MgSO4 solutions that's consistent with the drawing on the left. We're assuming these are the same size of containers. So, if I have 2 magnesium ions for a 1 molar solution, if I want the same molarity of sodium chloride, well, for every 1 magnesium chloride, I should have 1 magnesium ion. 2 magnesium ions represents 1 molar is what we're saying, okay? So that means 2 sodium ions would represent a 1 molar sodium chloride solution. And I would also have 2 chloride ions, because for every sodium chloride, I've got 1 sodium and 1 chlorine. Remember, we have twice as much chloride in magnesium chloride as we do in sodium chloride, so that makes sense that I would have 2 ions here, 2 chloride ions here, and 4 chloride ions over here. 1.0 molar magnesium sulfate, well, that's actually going to be much the same. 2 magnesium ions, 2 sulfate ions. Because I've got 1 magnesium ion and 1 sulfate ion for every magnesium sulfate formula unit that I would see. Let's do another one. In the 2 containers below, we have 1 liter and 2 liters respectively. We're going to draw particle representations of a 1 molar glucose solution that's consistent with the 1 molar magnesium chloride solution drawing above. So going back up, for 1 molar solution we had 2 magnesium ions. Well, glucose is not an ionic compound. It doesn't split apart. It all stays together in 1 clump. So I'm really just going to have 2 particles, and that's it. And if I had twice the volume, I would have 4 particles. Let me know if you have any questions. That sums up these notes.